Hey thinkers, welcome to this week's Thinking Podcast. I'm your host, Jeffrey Wu, and I have one of my most, anticipated guests on, Dr. Thomas Seyfried of Boston College. And he has been doing very interesting work and quite controversial in raising cancer, one of the, probably one of the biggest diseases facing us as a species, not as just a genetic disease, but perhaps a metabolic disease. So let's dive into that meaty topic. So, Thomas, loved for you to unpack that a little bit for me. What does that mean for the lay folks out there who might not have read up on your studies?
Yeah, well, I think thank you very much. It's nice to be here today. Well, cancer, as you mentioned, I think almost everybody in the world has a word for understands cancer. I mean, it's not. You could go almost any population on the planet and mention that word, and somebody would understand essentially what you're talking about.
Right.
So then the question is, how does it arise? Where are we getting this disease from? Why is the disease reaching epidemic proportions? What's going on with this? We have a serious problem today. According to the American Cancer Society, in the United States alone, we have over 1,600 people are dying every day from this disease. I would call this a problem. Yeah. And in China, it's like 8,000 people a day. It's in Europe, each country we're dying in large numbers from something that is universally known as cancer, right? I mean, this is the thing. So the question is, I mean, we're spending hundreds and hundreds of millions of dollars all over the world in trying to figure out what to do about this disease. And does anyone ask where all that money is going? What are people doing with all those hundreds of millions of? I don't think there's ever been another situation where so much money has been raised by so many people
for so little effect.
For so little, if any, but no effect.
Yeah,
it's getting worse, right?
Right.
The more money we raise to study cancer, the more cancer we get, right? So,
right.
What's wrong with this picture? I mean, basically, right. Why is this picture so distorted? One would think, we can throw money at a problem and the problem will eventually go away. We have an infrastructure problem in the United States. We're trying to raise money for infrastructure. So we're going to build new roads and new bridges, and eventually you're going to see new roads and new bridges. What would happen if we threw $100 million a day into infrastructure and the roads got worse? The more money we gave into infrastructure, the more bridges are falling apart. People say, what's going on here?
Right. Corruption or someone's incompetent. Something's wrong.
Incompetence, corruption. Well, why don't we use the same criteria to ask what's going on with this cancer thing? Right. I mean, we're running for breast cancer. We're running for lung cancer. We're swimming. We're jogging. Everybody feels good. The people who feel best are the ones who are running and jogging. They get healthy doing that stuff. But it's a tragedy. It's a tragedy that doesn't need to happen. And the problem is that we have been led down the wrong path as to what the nature of this disease is.
Right. It sounds like you're very much thinking about this from first principles. I think that's one thing that we constantly talk about in Silicon Valley or from an engineer's approach. Okay.
Yeah.
If what is the fundamental problem here? If all of our interventions don't work, well, let's look at first principles.
Right. The first principle is that cancer is a mitochondrial metabolic disease. And this view is absolutely obtuse to the view that cancer is a genetic disease. So the therapies that we're using and the massive research effort on the part of the major medical schools, the federal government, and the pharmaceutical industry is the view that cancer is a genetic disease. So the therapies that we're developing are designed to try to stop the proliferative signaling that these cells have. So they're growing out of control. That's the signature issue of cancer are cells that don't respond to growth signals anymore. They're unresponsive. They continue to proliferate and then we throw everything at them, including the kitchen sink, and the patient ends up dead or seriously injured as the result of what we try to do to stomp out the growth of the cells. I'm not saying that every person in the country who gets cancer is going to die from cancer, but the issue is many of these people are poked and prodded and stuck and poisoned and mutilated in the name of trying to cure them. And in many cases, people emerge by the grace of God. They emerge from this and they say, "I'm now a cancer survivor."
Right.
And most cancer survivors have been brutalized in one way or another. I mean, even though they say, "Well, the treatment wasn't that bad," and all this kind of stuff, but they were treated with toxic chemicals or radiotherapy or some surgical mutilation, and they've survived. But I'll tell you, their body remembers, okay? Their body definitely remembers. And all of those treatments for the so-called survivors impact in one way or another on the health and vitality of their body, the so-called survivors. The poor people, the 1,600 people a day dying, were not so fortunate. They probably endured a horrific litany of exposures and treatments over a number of different years, and finally their body just gave up, and they could no longer withstand the treatments from what they were experiencing. So this is what we have. We have a lot of cancer survivors, and we have a lot of people dying every day. And they don't say that. Listen, if we recognize this is a metabolic disease, and we have a very clear strategy as how we're going to stop this disease, and we're not going to hurt you. Now, who hears that? No one, right? You don't any top medical school, and they're going to tell you, "Listen, Mr. So-and-so, Mrs. So-and-so, we have a therapy here that we will gradually remove the tumor cells from your body without toxicity. You're going to have to play a significant role in the management of your disease, but we'll be here to help you. We're going to guide you through this system, and it's going to involve a series of procedures that are not toxic, not harmful, and some drugs that are going to be very minimally dosed, so you won't have to suffer in any significant way. And it's going to require some level of participation on you, Mrs. So-and-so, for you to collect some of the information that we're going to need so that we can make the appropriate adjustments in your care so that you end up through this process actually healthier than when you started."
Right.
Now, this is the plan that will absolutely work for the majority of people. So why, when you go to the Cancer Treatment Centers of America, Dana-Farber Cancer Center in Boston, MD Anderson in Texas, UCSF where you are, right? Sloan Kettering in New York City, why you hear that? Why don't? So people say, "Well, that's preposterous. There's no evidence for this." And I said, yes, there is plenty of evidence. You just choose not to look at it.
Right. And there's no money from the pharma companies for talking about nutritional ketosis as an intervention.
Well, a lot of people raise this point. I think that if the society, every member of our society, man, woman, and child, comes to the realization that my disease cannot be effectively managed unless it can generate significant revenue for the pharmaceutical industry, and I'm okay with that. But that's so.
That's a fucked up society, right? Like we should change society if it really is like that.
Well, that's the situation here,
right?
So when we look at a cancer patient today, we say we're sorry that you have this disease, but look at the good side. Your sickness is maintaining a major, powerful industry in this country.
No one cares.
This is basically what it is.
Yeah, that's an interesting way to look at it. Yeah.
You have to look at this in many different ways, and the issue is that we are, as a society, accepting of this philosophy because we are not told or educated in understanding the biological nature of the disease.
Right.
Okay. And when you look at the top medical journals and research articles, it goes over the head of most people. It's mesmerizing. Look at all these little figures and diagrams and look at all this kind of stuff they were doing to these people. Oh, I never figured this. I got to leave it to the experts.
Right.
Well, who are these experts? If they're so expert, how come all these people are dying all the time?
Right.
So obviously, when you say, "Oh, he's an expert in cancer," Well, then why does the disease keep increasing every year? If it,
Yeah, I mean, proving the pudding. If you're an expert, you should be solving or making traction against it.
yeah, or he says, well,
Absolutely.
my patients survive long.
So why do you think that the genetic explanation has been so sticky? I mean, so basically, as a summary, sort of the genetic basis or the explanation is that there's some mutation in the DNA in the cell that mutates it, and it ends up proliferating because
Yeah.
it's uncontrollable growth.
Yeah.
And then you have these cancerous cells that turn into tumors, and these tumors break off into more cells and metastasizes, and you die because you have all these like
Yeah. Yeah.
bad cells floating around.
Right. Right. Well,
Why is that explanation so sticky? And then and I'd love for you to explain.
yeah. So I mean, we're not denying that there's genetic mutations in the cancer cells. The tumor cells are loaded with genetic mutation. I mean, you look at a cancer cell, the genome is shot to hell, as many scientists have said, right?
Right.
So, but they think that's the cause. They think that's the origin of the problem of it. That's an effect. That's an effect. It's a downstream epiphenomenon. The genome goes to hell because the cell can't produce energy the way it used to produce energy. So you're studying effects, not causes. So for example, let's just briefly consider, where does cancer come from? How do you get cancer? Many people can get cancer from many different ways. Okay. Some people work in a tetrahydrochloride factory. They get exposed to a chemical. Oh my God, you got a brain tumor. There's a link between that chemical and brain cancer by epidemiological analysis. So there's a real possibility your job gave you that tumor. Okay, so you got that tumor because you were exposed to this chemical. Somebody else may get a tumor because they've been exposed to urethane or some other carcinogen. So we have a whole list of so-called carcinogens. Those carcinogens damage the respiration in the cell. So we're alive, and I'm talking to you, and you're talking to me because we're breathing air. If you hold your breath for about 5 minutes, you will not be talking to me. All right? Your face will be purple and you'll fall out of your chair.
Pass out.
Right? Yeah, right? Me too.
Yeah.
I'm going to hold my breath. All of a sudden, oh, what happened to him? Oh, he stopped breathing. Well, what happens when you stop breathing? Well, your cells start dying, right? I mean, so what happens in cancer is that these chemicals, it could be a radiation, it could be a viral infection, it could be inflammation, systemic inflammation in the body, it could be old or age, gets damaged to respiration. Whatever happens in multiple different ways, our cells, a group of cells in a particular organ, in a particular person, stop breathing effectively. Okay, now I just said if you stop breathing effectively and oxygen just goes away acutely, those cells are dead. Yep. You can never get a tumor from a dead cell. So what happens is these insults, the chemical carcinogen, the virus, or the age, or the inflammation, or the hypoxia, all the different causes that we know, don't acutely damage the ability of that cell to breathe. It happens slowly. Okay? So what happens now is the cell, in order to stay alive, has to find another way to get energy. And that way of energy is called fermentation. Energy without oxygen. Energy without oxygen. Oh, where did you get that from? Where did energy without oxygen come from? Our Earth is very old. Okay, people have to know that the Earth is like 3.5 billion years old. Right. We had organisms on our planet that were happy and living in an atmosphere that had no oxygen.
Right.
They were fermenting. When oxygen came into the environment, organisms started to breathe air, oxygen. All right. So what these cancer cells are doing are falling back on an ancient pathway to get energy without oxygen. And what happens? What were those organisms doing 2.5 billion years ago when there was no oxygen? Guess what? They were growing like crazy. There was unbridled proliferation. What else do we know has unbridled proliferation? A cancer cell.
Cancer. Yep.
Okay, so the cancer cell is falling back on an ancient pathway which was associated with unbridled proliferation. And this is what's happening. Now, what did those ancient cells eat to grow so fast?
Sugars
and amino acids, right? That was what was in the soup, in the environment. Today, we have processed foods. We have all kinds of wonderful things that make us feel good in our environment, right?
Right.
So when you look at a bunch of cancer cells that are growing like crazy, the first thing you say is, what are they eating? What are they using to grow so fast? and they're using glucose and glutamine and these amino acids.
Right.
Oh, what happens when I take glucose and glutamine away from the cancer cells? They die.
Right.
Very simple. Okay, how do I do that in a person who has a tumor? Okay, well, you put them on a calorie-restricted ketogenic diet that lowers blood sugar and raises a ketone. Well, what's this ketone thing? If you stop eating for several days, your body, all the fat that we store in our butt, in our gut and area places, right? Our body takes that, brings it to our liver, breaks it down like putting a log into a wood chipper. So you take these long chain fatty acids and chop them up into these little water soluble things, and they go and they support the energy in our because we're breathing oxygen. They're beautiful fuels for that. Guess what? The cancer cell can't breathe. The cancer cell can't use those things. Right? So what is the cancer cell using? It's using glucose and this other thing called amino acid, glutamine. The most abundant amino acid in our body is glutamine. So the tumor cell now, to survive, is taking in glucose and glutamine, and they're surviving like crazy. But if you lower the blood sugar, and you force feed them these ketones, they start choking. They can't chew this. They can't eat this stuff. So we use ketogenic diets, and of course, then we use a couple of small drugs to push those blood sugars down. We can push those blood sugars down enormously low.
Metformin, like basically diabetic or drugs.
That's so weak compared to the things we can do. Why do metformin when you can do 2-deoxyglucose and a couple of other drugs 10 times more powerful than metformin? So they love metformin. Wow, metformin. Metformin's not going to cure cancer. Let me tell you that right now. Right. So I'm not saying it's going to hurt you. I mean, you might be able to throw a little bit of that on there. It's that we're going for the throat of this disease. We're not just pussyfooting around with it. So you push the blood sugar down. Now these tumor cells are at risk, right? And guess what? When you lower the blood sugar, all the normal cells in your body want that sugar. So they start putting out feelers for the sugar. And the next thing you know, they're stealing the sugar from the tumor cell that really needs it to survive because they can't use the ketone bodies.
Right.
Beautiful, elegant, non-toxic, elegant. So, and then we just throw in a little drugs that stress the glutamine level. And we put the patient in hyperbaric oxygen chamber only when they're in therapeutic ketosis. So guess what? The tumor cells use glucose and glutamine. They put a protective shield around themselves because so when you go to irradiate them or use these toxic poisons, they say, oh, these tumor cells are so tough. They resist and they adapt to all this stuff because they're using glucose and glutamine. It's the shield. It builds antioxidants inside the tumor cell. So the very fuel that they're using to grow puts a protective shield around them against radiation and chemo. So
you're killing your healthy cells more than you're killing the cancer cells in some odd way.
Get a load of this. Here's what's another bizarre thing if you want to know how absurd this whole cancer field is. So because you get sick from the chemo they give you, they often give you steroids to increase your appetite, to make you eat more. And then the steroids, I'm sick as a dog because the guy poisoned and irradiated me. Now I'm going to give him steroids to get his appetite back. Steroids raise the blood sugar, makes the guy eat more, and fuels the tumor cells.
Right.
It's insane. It's absolutely insane.
It's a horrible cycle.
Yeah, it's because people don't know what they're doing. They don't understand the biology of the disease. If they really understood the biology of the disease like we and several others do, you would never do the things you're doing to these cancer patients.
Right.
It's insane. It's absolutely nuts.
Yeah, and it sounds like there's emerging research and case studies that are proving your thesis here. That focus on
this thesis was proven by Otto Warburg a long time ago.
Right. It's interesting because it seems like along the same time, the case against fat was litigated. We had Gary Taubes who wrote some of the books around how sugar was pumped and fat was demonized, and now our diets has really shifted towards something very amenable to the metabolic theory of cancer. So I think it's like, do you think those are tied together? Like, I mean, it sounds like there's like a 1-2 punch here where you see both of these curves going up at the same time.
Right. I think this is it's just a matter of time, because we're working with physicians in different countries that have a little bit more flexibility. They're not yoked into treating cancer with this rigid standard of
Right.
care that you must do, otherwise you can lose
Right.
your license to practice medicine.
Right.
This is another crazy thing. So they have no flexibility. You got to mutilate people, you got to nuke them and poison them to make them healthy.
Right.
This is what you got.
Absolutely.
And they have all shapes and sizes of these different procedures to fit your own personal lifestyle. You know what I'm saying?
Yeah.
Taking somebody's breasts off or removing their prostate or colon or something like this. We got the surgeons in there, and then we got the chemical guys, and then we got the radiation guys, and we got all these guys, and they're all doing that. You don't need to do any of that. All you have to do is starve the cell of their two prime fuels and put them into hyperbaric oxygen. There's a few other things that I haven't gone through. But it's not that complicated.
Right.
So the argument is, where's the clinical trials to prove this? We don't believe anything until we have a clinical trial.
Sure.
Okay. We have almost 100 years of hard biochemistry to say that what I'm saying is absolutely correct. Otto Warburg supported this. And and Otto Warburg's research has been verified, validated over and over again. You don't need a clinical trial if you have a few functional brain cells to read the literature, right?
Right.
Okay, that is just going to confirm what we already know from preclinical models and from a lot of hard science.
Right.
This is not hocus pocus mumbo jumbo. This is based on hard, rigid, replicable science.
Right.
So you say, why is it not being done in the clinic? Because we have a culture of cancer as a genetic disease with a series of therapies based on stopping the proliferation by smashing the DNA, by doing all these other kinds of things.
Right.
You can achieve the same thing without toxicity if you starve them of their fuels. And you have
it just seems like almost in every domain there's a few key thought leaders, and obviously I know doctors out there are trying to do well and good, but they're just trained in a system that's indoctrinating them as treating as a genetic disorder.
Yes, it's a tragedy, and you don't see these poor people, these physicians, that being trained in knowing how much radiation you need to give a person before you start killing them. It's what are you doing that in the first place for? You don't need to do that. Well, we have to do that.
It's like amputating limbs before penicillin existed, right? Like I'm sure those surgeons, battlefield surgeons, thought they were doing good. They were going to amputate so you don't die of gangrene. But now we have new technology, new understanding, or at least old understanding coming back. To be like, hey, there's a smarter way to do this.
Yeah, well, it's also a dogma. A dogma is it's an irrefutable truth. It's a mindset. Dogma is what we have in religion. Okay, it's powerful. When you have a dogmatic view, you cannot change. It's a cultural dogmatic view of how something is. And let me tell you, a dogmatic view is more powerful than any gene that has ever been defined on the planet. A dogma is so powerful in controlling the way the mind views the world.
Right.
I mean, there was a time when many scientists thought the Earth was the center of the solar system, and the sun revolved around the Earth. And if you challenged that dogmatic view, you were either executed or banned or
excommunicated. Yeah, you're basically hunted down by the Inquisition or excommunicated.
To say that I support Copernican view of the solar system, you were thrown in jail or killed like Bruno.
Yeah.
So we have the same dogma in the cancer field. It's just as powerful as what the heliocentric resistance to the geocentric view of the universe.
Right.
It's that powerful.
Yep.
If you go to a top medical school and say, listen, Dr. So-and-so, I would like you I would like my cancer to be managed using metabolic therapy.
They'd be like, "You're nuts! You're doing some woo-woo like Steve Jobs crazy stuff." But it's not. It's not like this is some real fundamental science here.
And then,
I agree.
And then what they'll say, and this is what happens all the time. Well, this guy will say, "Yes, I've heard of that. I'm not really sure whether it's going to work, but I'll tell you what I'll do. Let me do the standard of care first, and if it doesn't work, then maybe we'll consider metabolic therapy." Right. And all right, so you're going to poison and irradiate me, and I know, like we have a huge literature to say, and I'm not going to survive very long if you do this, and you want to do that to me before you want to do something else. Right. It's just so you're locked into the dogmatic view of what you have to do.
Yeah, no, I feel like we see a tidal shift of of community and people that are looking at the research from and data from firsthand. So as you might know, in the biohacking community that we have, listening to the podcast, a lot of us do intermittent fasting. So I personally do a 36-hour fast every single week.
Yeah.
I eat fairly keto. I'll cycle in and out of ketos, a ketogenic diet. And my intent was not, when I first started fasting, was not to, ward off cancer. Although I think in some of your recent literature, you're talking about, preventative measures using fasting to prevent cancer development. But it was mainly for optimization.
Right. Right.
I'm a relatively healthy
Right.
person. I don't need to lose weight, but there's very interesting benefits of ketones or ketosis over glycolysis that I want to tap into for energy, more metabolic efficiency.
Right.
I think if you just look at the interests of the communities and the Google trends of ketogenic diets, ketosis, exogenous ketones, I think you see a groundswell.
Yeah.
And on top of that, on top of like the case against sugar, with some of these popular science writers, I think we do see a tidal shift in community and in popular opinion that, hey, maybe there's something we can shift with our diet, with our protocols to enhance not just performance, but also potentially prevent disease.
Yeah, well, that you're absolutely right about that, and that's why we published the glucose ketone index calculator, which is a way for everyone who wants to get like you. And in other words, if you do a 36-hour fast, you have to ask yourself, am I in therapeutic ketosis?
Right.
All right. So, and the answer is we developed this because of the problem. It was actually done to help cancer patients, but we're realizing now the general population seems to be more interested in this than the oncology community. It's really amazing because my students and I built the glucose index cal, which is extremely simple. You take the little meter, which is a MetaSense meter from Abbott. You can get them on Amazon. I think they're only about $35 or $40. And then
the Precision Extra, basically a ketone meter and a glucometer.
Yeah, glucometer. So we tried to get Abbott. We asked Abbott, you should put the calculator in your meter. Oh, there's no market for this, right? Because they're looking at type 1 diabetics as their only market.
Right.
All of a sudden now, you and thousands of other people are looking into this, and they're saying, hey, how do I know if I'm in therapeutic ketosis? So we built and validated it on normal animals and people and cancer. And if you can get a ratio of 1.0 or below, you're in therapeutic ketosis. And some people get them down to like 0.7, 0.8, really low ratio.
So it's glucose over ketone, blood beta hydroxybutyrate.
Yes, but what's so interesting is that the meters read the blood sugar in milligrams per deciliter, and they read the ketones on the same drop
in millimoles.
In millimole. Okay.
Right.
So you have to convert milligrams to deciliter into millimole, so you can divide millimolar by millimolar, and then you get this unit value. It's a singular number. And for example, if you go out and eat a big lunch, just say you have big bowl of rice and some nice piece of meat and potatoes or whatever you're going to eat. Well, you're going to have very low ketones, and you're going to have very high blood sugar. So if you do the ratio, you'd probably look at a number about 40 to 50 would be your GKI. Well, to be in therapeutic ketosis, you need to be 1.0 or lower. Right. So you're not going to be eating potatoes and rice and bread.
Right. So quick back of the envelope calculation. To convert milligram over deciliter, you need to do times or millimole to milligrams is you got to do times 18.
Yes. Yeah.
So yes.
Yeah. So you divide the milligram per deciliter by 18, and that gives you the millimolar. Now the calculator does all that for you.
Right.
So as a matter of fact, the company just licensed that from us. It's called Heads Up Health. It's out there in Silicon Valley. Okay. One of these guys that was working in Silicon Valley decided that he needs to. So he set this little app up, Heads Up Health. And what it does is it takes the calculator, and also it monitors how much you eat, what kind of food you're eating, what your exercise level is, all the different things that you would do in a course of the day. And then you get your GKI, your glucose ketone index, and then you'll know precisely whether you're in therapeutic ketosis or not. Right. And it just gives you the power to know. And then people share this information with each other. Hey, I ate this and I didn't throw myself out of ketosis. Right. And it becomes like a big game. Oh, what are you doing? And then we found out that dark red wines don't throw you out of ketosis. But beer, oh yeah, you can. And then people share. It's like a community of people
Right.
sharing all of the.
I'll definitely have a link to that because I think a lot of, I have finger pricked myself many, many times.
Yeah.
So I know general the ranges of all of that. So it's actually not trivial to get to a 1.0 ratio.
No.
I mean, I'm just thinking about it like for myself. I mean, getting to, 3.0,
Yes.
4.0 millimolar ketones is non-trivial.
No, it's not. No, it's hard.
I mean, it's very hard to do it nutritionally. I think
Yeah.
I've tried to do it nutritionally, and I think you get maybe 1.0, 1.5.
Well,
if you fast,
Yeah,
you can get into the 2.5. I did a 7-day fast in January and hit 5.4 millimole.
Yeah.
So
Yeah, you're in a very select group. Let's put it this
Right.
way. Let's go around. Let's go down to a local bar and ask these guys to fast for 7 days, right? What kind of response you're going to get? Even in San
You'll be like,
Francisco,
"Who-
even with all those people out there, there's not going to be many people like.
Yeah, no, they'll be like, "What the hell? How is that even possible? Are you going to starve to death?"
When I told my father when he was sick before he passed away, he had diabetes. I said, "Dad, you got to fast for 7 days to get healthy." He looked at me and says, "You do it and tell me what it's like."
Have you done extended
No,
fast?
the longest I've gone was 3 days.
Okay.
I haven't pushed myself to this. So, we're not here to torture people.
Right.
And I'm not saying making people do a 7-day fast. If you do it because you want to do it, that's okay. But, when you're sick and you've got cancer and then somebody tells you, hey, you can't eat for 7 days, they don't want to hear that. All right.
Right.
Is there any other way?
But otherwise, I think you might want to hear that over, hey, take a lot of chemo,
Yeah.
get irradiated, and then get opened up, right? It's like, I'd rather not eat for 7 days.
Well,
it's not.
you don't have to do that. You just have to stop eating for maybe 24 hours or 36 hours just to get your body a little prepped.
Right.
And then we use the ketogenic diet, a well nutritionally balanced ketogenic diet that will bring you into therapeutic ketosis much faster, much higher, with a lot less difficulty.
Right.
So rather than going for 7 days without eating, well, yeah, you'll be in therapeutic ketosis. There's no question about it. But can I get there a little faster and a little easier?
Yeah. Have you looked at exogenous ketones, ketone salts, ketone esters?
Yeah.
I think that's an area of interest of us personally because, hey, there's a lot of interesting research coming out of the Clark-Veitch groups around, hey, you can really pick up your blood ketone levels really, really quickly.
Well, it can, but you got to be careful about some of those things. Not that I'm saying some of them, because I have friends that are working in the field and they do this and that. But you got it. But very few people are doing that while measuring their GKI. They're not using the meters. So in other words, you're in therapeutic ketosis, hypothetically. Okay, let's drink a glass of this ketone mixture that this guy just told me about. All right. Well, great. What is that doing to your index now? We don't have the common guys like you and others who here, let me show you my data. And look here's when I just drank the ketone. Look at how, oh man, I got into a higher, but how long did it last? Right. You can only last in those zones for a very short period of time. So what I'm not saying that they can't help us, but if you look at the ingredients on some of them, they have too much carbohydrate in there. If you have any carbohydrate while you're drinking, you're going to piss it right out. And then you're going to take the urine stick and say, look how high my ketones are. It's coming out of your system as fast as you're making it.
Right.
So your body is excreting it. It's only when your blood sugar is low that your body is going to keep those ketones in your body, and you're going to stay in sustained therapeutic ketosis. So that's why you need the blood meter, not the urine sticks.
Right.
You really need.
Absolutely. Yeah, I think blood is definitely the core biometric. I know that for certain ketone esters, I mean, if you can't pick it up because it's being processed through, being processed. Absolutely.
You really need the blood and to get the real accurate index.
Right.
And you don't have to do it every day. I know the cancer patients, some of them do it every day because they want to know if they're 1.0 or below, they're killing tumor cells. All right. So they got a motivation to do this. Right. But I'll be surprised. I mean, I'm surprised at how normal, healthy young people pride themselves in getting ratios below 1.0 and then bragging that I kept my index below 1 for 3 days. It's like, it's like running the marathon here.
I think there's definitely a tidal shift in thinking about how we treat our bodies as a system. I think it's very much that the hacker ethos to be like, hey, I want to be the most optimal, productive version of myself.
Right.
Yeah, absolutely.
And as I said in my book on chapter 19 for cancer prevention, If you
Right.
can get yourself down into therapeutic ketosis for 3 to 5 days, you're blasting the crap out of these incipient tumor cells. Your body is
Right.
going through and it's just gobbling them up and eating them. So
Right.
before they can take off and start growing as a neoplasm, which is an dysregulated growth of cells, your body is killing them. So so therapeutic ketosis, I always say, is a place to visit, but it's not a place to live. All right, you visit the zone periodically, but you don't live in the zone. Living in the zone changes the way your brain works. All right, you start to become a different person in many different ways.
Interesting.
Yeah,
I'm curious. Yeah. So basically, if you're just fully ketonic all the time, you're saying that, hey,
you have to avoid so many things in the environment to maintain constant therapeutic ketosis. Therefore, your social interactions change. Your view of the world changes. Your whole mind of yourself in the universe changes. So, this.
That was part 1 of this week's episode of the Thinking Podcast. Stay tuned for part 2 next time.